All right, let's look at this first question. So number 1 says, what is a 16th term in row 53 of Pascal's triangle? So remember with that, it's just going to be 53. Choose, and the fact that it's a 16th term means we use one less than that. The reason why we use one less than that is because the first term in Pascal's triangle would be choose 0. So the first term in row 53 would be 53, choose 0. And then counting down the row as we get to the 16th term, again would be 53, choose 15. Now just to let you know, this would be a huge answer. If this were the test question, I would probably just have you find out what the R value would be. I wouldn't write if this were the question. I wouldn't actually ask you to find the total, because the total is going to be, like I said, this giant number, which we can put in scientific notation. In fact, that's what your calculator will probably do, which would be 6.25 times 10 to the 12th power. Because if you have 6.25 E12 on your calculator, that means it's in scientific notation. So we put it as 6.25 times 10 to the 12th. All right, this is the one, though. Number 3 is a question that a lot of people had problems with. So let's look at how we would do that. So you want to remember that when we're using the binomial theorem to expand this out, the fact that this is the degree is 4 means we're going to use the 4th row of Pascal's triangle. So we do 1, 4, 6, 4, 1. Now notice how much space I gave myself there. I gave myself plenty of space because there's going to be more to follow each one of those values. So then what I'm going to do is I'm going to go to the x. And so we would have x to the 4th power. And then I'm just going to do it this way. So I'm going to go in descending order with that x all the way down to x to the 0 power. And then we have, whoops, it's important to include that minus because I think that's where some of you guys had a hard time. And then knowing how to simplify when you have a negative. So this is a negative 2y. That's the way we need to look at this. Okay, don't think of it as minus 2y. Think of it as a negative 2y. So we're going to have negative 2y to the 0 power. And then from there, we're going to go up. So we'd have negative 2y to the first. And then we'd have negative 2y squared. And then we'd have negative 2y cubed. And we'd have negative 2y to the 4th. Now we're going to simplify each of these. Now, negative 2y, anything to the 0 power is 0. I'm sorry. Anything to the 0 power is 1. Don't misunderstand me there. Anything to the 0 power is always 1. And so that's 1. And 1 times 1 doesn't change anything, so we would just have x to the 4th would be our first term. Now, the next term, negative 2y to the first. Remember, that's not a minus 2y, that's a negative 2y. Negative 2y to the first is negative 2. But we're going to multiply that negative 2 times 4 and get negative 8. So we'll have minus 8 x cubed, and then we'd have y to the first. So the sign is very important. And this is all one term. You should not have like a minus in between here. Otherwise, that breaks it apart into 2 terms. So that's why you want to put the minus out in front. So we treat that as a negative 2. Because negative 2 to the first is negative 2. Multiply that times 4, and you get negative 8. So we put the negative 8 as the first part of that term. All right, looking at the next term. So the next term, we'd have negative 2, but we have to square that. Negative 2 squared is a positive 4. And 6 times 4 would be a positive 24. So we'd have 24x squared. And then the y would also be squared. Notice as we go down here, every term, the degrees should add up to be 4. So in the second term there, 3, and then that y has an exponent of 1. Since there's nothing listed there, it has an exponent of 1. So 3 and 1 makes 4. The one that we just did, 2 and 2 makes 4. So you just want to make sure that you're repeating that pattern. Okay, looking at the next term, we'd have negative 2, but that's going to be cubed. Negative 2 cubed is negative 8. And negative 8 times 4 would be negative 32. So we have negative 32x, and then the y would be cubed. Again, my exponent there for the x would be 1. So 1 plus 3, sure enough, is 4. And lastly, just like at the beginning, x to the 0 power is 1. 1 is 1. That multiplying that times the negative 2 to the 4th is not going to change anything. But negative 2 to the 4th power would be a positive 16. So it would be plus 16y to the 4th. And that is how you get your answer for number 3. All right, let's look at number 4. It says, find the mean and standard deviation of a binomial random variable with 300 trials and a chance of success of 0.35. So that means p is 0.35. And since we want to find the mean and the standard deviation, for the standard deviation, we're also going to need to know q. Q would be 1 minus 0.35, or 0.65. So to find the mean, we just take the number of trials, so the 300, times the probability of a success, which is 0.35. When we do that, when you multiply those together, we get 105 as your answer. So that would be your mean. The standard deviation is the square root of n times the probability of a success, 0.35, times the probability of probability of a failure, 0.65. And so when you multiply those together and take the square root of it, you end up getting with a standard deviation of approximately 8.26 if we round to the nearest hundredths place. So that's how you do number 4. So look at number 7. 7 says, suppose the probability that a student will pass a driver's test on the first attempt is 68%. Find the probability that exactly 14 students in a class of 20 pass on their first attempt. All right, so that tells me that we have, so the key word there is exactly. Okay, so we're only going to do one value here, so we'd have just 20 students in the class, and we want to find the probability that exactly 14 of those students pass. Now they have a 68% chance, a 68% chance of passing, so it'd be 0.68 would be a probability of success, and again, 14 of them are going to pass. Well, that means if you have a 68% chance of passing, you have a 32% or 0.32 chance of failing. And if there's 14 that are going to pass, that means 16 are going to fail. I'm sorry, 6 are going to fail, because you want to make sure that these two numbers add up to be 20. All right, so when you go to do this on your calculator, you end up getting 0.188 as your answer. So that would be your answer for number 7. All right, number 8, it says find the mean and variance of the random variable. Now this is not a binomial probability, because a binomial probability means you only have two possibilities, a probability of a success and a probability of a failure. Here we have a 0.24 chance of getting a 3. So this is X represents the number of hours per week that they spend on their homework. So 24% of students spend 3 hours on their homework, 41% spend 6 hours, and so on. So the only way to find the mean of this is to multiply the number of hours for each one, so your values for X, times each of their probabilities. So we could take 3 times 0.24 plus 6 times 0.41 plus 8 times 0.15 plus 9 times 0.04, I might run out of space here, plus 11 times 0.04, spill this down here, and then plus 13 times 0.12. So when you do all that on your calculator, you end up getting, like I said, your mean is going to end up being about 6.74. So that's the mean. Now to find the standard deviation, we're going to do the same thing. We're going to square each, but it's going to be a bigger process. We're going to square each of those. We're going to do that first. So we take 3 squared times 0.24 plus 6 squared times 0.41. Now if I was typing this in my calculator, I would not type in 8 squared. I would just do myself a favor and just type in 9 times 0.24 plus 36 times 0.41. You're smart enough, you know how to square these. You might not know what 11 squared or 13 squared is, so you can type that in, but just as I'm doing it on my calculator, that's what I would do. So we have plus 9 squared times 0.04, and then plus 11 squared times 0.04, plus 13 squared times 0.12. Now it's important that you do all of that on your calculator all at once, okay? Or all of that piece in one step. You don't want to do all of this, because this is not your answer. This is just the first part of it. So you should get approximately 134.73. Now what we're going to, excuse me, what we're going to do is we're going to subtract the original mean squared, the 6.74 squared. And what this is going to do is this is going to give us our variance. When you take 134.73 minus 6.74 squared, you're going to get an answer of, let's see, what did I get? You get 89.3024. The key is you're going to take the square root of that. When you take the square root of that, you get your final answer of approximately 9.45. So 9.45 would be your standard deviation. So that's how you do one like number 8. All right, let's look at number 10. Number 10, it says, a restaurant dessert menu has 3 custards and 7 pastries. A group of patrons decides to order 2 custards and 5 pastries. In how many ways can they do this? Well, here's how you're going to set this up. So first off, we're going to look at the totals. So there's 3 custards and 7 pastries. Okay, so we're going to have the first one represent the custards. The second number there is going to represent the pastries. And a group of patrons decided to order 2 custards. So there's 3, and they're going to order 2 of them. And there's 7 pastries, and they're going to order 5 of those. So what we're going to do is we're just going to multiply those together. When you do that, you get an answer of 63. All right, let's look at number 13. So this is one of those problems where it's just in general terms as far as what's happening to a graph. So you could play around with that tool that I showed you on Wednesday for lesson 10.6. And basically the idea here is that as you increase a value for p, how is that going to impact, what effect is that going to have on the graph? And then the graph basically is going to shift from left to right. So it had a tail kind of going off to the right, but then as we increase the value for p from 0 to 1, it's going to move everything. That's going to move the graph. So like the mean and the median are all going to also shift to the right. And so that's what happens with number 13, is that the data, the graph, just shifts to the right is how you can word that. All right, let's look at numbers 2 and 3. We'll go ahead and look at both of these. These both had a lot of questions too. Let's start with number 2. So in number 2, we're dealing with the 6th row of Pascal's triangle. Now you could look at what the 6th row is. Remember, you should have the 4th row of Pascal's triangle memorized. The 5th row would be 1, 5, 10, 10, 5, 1. So the 6th row would be 1, 6, 15, 20, 15, 6, and 1. If you're wondering how I got that, all I'm doing is to get the numbers in Pascal's triangle, we just add the numbers next to each other in the previous row. So for example, 1 plus 4 gives me 5, 6 plus 4 is 10, 6 plus 4 is 10, 4 plus 1 is 5. It always starts and ends with 1. So here 1 plus 5 is 6, 5 plus 10 is 10, or 15, 10 plus 10 is 20, 10 plus 5 is 15, 5 plus 1 is 6. So that's how I came up with those numbers. You don't want to forget our ones there as well. So it starts with the 1 and it's going to end with the 1. So we're going to use those. So I'm going to start with that. So we'd have 1, 6, 15, 20, 15, 6, and 1. Don't need that anymore, so I'm just going to put my pluses to the left of these. So I'm going to do this in a couple different steps. So the next step is we're just going to start out with x, and we'd have x to the 6th power, and then that's going to go in descending order. All the way down to x to the 0 power. So we get that from this one. Now the next one is a -3, and that's where some of you guys are having problems, is negatives. So we would have -3 to the 0 power, and then we're going to have -3 to the 1st, -3 squared, -3 cubed, -3 to the 4th, -3 to the 5th, and finally -3 to the 6th. All right, so now what we're going to do is to simplify this. This is going to require a little bit of work here. To simplify this, anything to the 0 power is 1. Even -3 to the 0 power is a positive 1. So that would be 1. This would be 1. So we're going to start out with just x to the 6. Now here's where it starts to get a little bit trickier. So here we have -3 to the 1st. That's -3 times 6 is -18. And then we would have x to the 5th power. Now the next one, -3 squared, that's a positive 9. And now we're going to take 9 times 15. 9 times 15 would be 135. And that's a positive 135, so you'd say plus 135. Then we have x to the 4th. The next one, -3, when we simplify that, -3 cubed is a positive, I'm sorry, not a positive, a -27. So -3 cubed would be a -27. And now we're going to take -27 times 20. When you do that, you get -540. So this will be minus 540 x cubed. Now in the next term, we have negative 3 to the 4th power. That's going to be a positive 81. And 81 times 15 would be a positive 1,215. And that would be x squared. Now the next one, we're going to take negative 3 to the 5th power. So that's going to be negative 243. But now we have to multiply that times 6. So that's going to be a negative 1,458. And that would be x to the first. And lastly, negative 3 to the 6th power is 729. That'd be a positive 729. X to 0 power is 1. This is 1. Those don't impact that at all. So this would be plus 729. So there wouldn't be any variables there. So that would be your answer for number 2. So let's look at how we would do number 3. Number 3 is actually going to be a little bit easier. It's not going to be quite as large. But we're going to start it out the same way. We're going to start with the row from Pascal's triangle. 1, 4, 6, 4, 1. Okay. Next, we're going to look at the first term. We'd have 3x. So I'm going to start out with 3x to the 4th power. And then we'd have 3x cubed. Now notice what I'm doing here. I'm putting this 3x in parentheses with the exponent outside of it. That's important because if you don't do that, then you're not going to remember to apply the exponent to the 3's. Okay, next we have negative 4. We have negative 4 to the 0 power, negative 4 to the 1st power, negative 4 squared, negative 4 cubed, and negative 4 to the 4th power. So let's go through each of these. So for the first one, negative 4 to the 0 power is 1. 1 again doesn't have an impact. 3 to the 4th is 81, so we're going to have 81x to the 4th. Over here, so the next term, negative 4 to the first term, or negative 4 to the 1st power is just negative 4. And we have 3 cubed. 3 cubed is 27. So we have 4 times 27 times negative 4. When you do that, you get negative 432. And then we have this x that's going to be cubed. So we'd have x cubed. Let's go to the next one. So the next one, we would have 6. 3 squared is 9. So if you want to do it this way, that's fine. 9x, so we'd have 9x squared. And negative 4 squared would be a positive 16. So now when I take 6 times 9 times 16, that's going to give me a positive 864. Oops. 864, and then we have the x squared. The next one, we would have 4 times 3 to the 1st, which is just 3, times negative 4 cubed. Negative 4 cubed would be a negative 64. And now when you multiply 4 times 3, which is 12, times negative 64, that's going to be negative 768. And then we'd have x to the 1st, or just x. Lastly, 1 is just 1. 3x to the 0 power, that's 1. It's not 1x, it's just 1. And negative 4 to the 4th power is a positive 256. So that would be your answer for number 3. Okay, so 7 and 8, there weren't a whole lot of questions on these. I think only about one student each on both of these. But this is where, so if you didn't know how to do this, this was probably because you didn't watch the video for lesson 10.7. So lesson 10.7 was all about these binomial probabilities. And so all you have to do here is take, to find the mean, you take the mean, the number of trials times the probability of success. So for number 7 here, we would just take, to find the mean for 7, that's symbolized by this, we would just take 100 times 0.3, and when you do that, you get 30 as your answer. And the standard deviation looks like that. That's the square root of n times p times q. So 100 times 0.3, if 0.3 is the probability of a success, 0.7 would be the probability of a failure. So if you take the square root of 100 times 0.3 times 0.7, you get 4.58. So you get your answer for 7. For number 8, same thing. To find the mean, we take the n, the number of trials, times the probability of success. We take 80 times 0.6. When you do that, you get 48. To find the standard deviation, we take the square root of n, which is 80, times 0.6, times the probability of a failure, which would be 0.4. And when you do all that, you end up getting 4.38 as your answer. All right, let's look at number 18. It says, give a formula for b of x, a probability of exactly x successes. So here we have, they just want to, just a general formula for this. So here we would have n choose r. Okay, that's always how you start those out. And then you multiply times the probability of a success. And then that would be whatever to whatever r is, whatever exponent r would be. And then we'd have q would be a probability of failure. And then that exponent would just be 1 minus whatever r is. So that's the general form. Well, I guess they wanted x successes. So we would have an x here. All right. Now for number 19, it says, if n remains constant, so the number of trials stays the same, what happens to the graph if p increases from 0 to 1? This is very similar to question number 13 in the self-test, and that's just going to be that the graph shifts from left to right. For number 20, if n remains constant, so the number of trials stays the same, what happens to the mean and mode as a probability increases from 0 to 1? So what's going to happen is the mean and the mode will both also increase, okay, to whatever n is. Okay, so that's, and you could, again, so as far as how you'd get these, you can just open up that graph that I shared in the notes for lesson 10.6, and that's how you can access that and play around with that and know what's going on with those. For 21, it says if p remains constant, so the probability of success remains the same, what happens to the graph if n increased from 2 to 2,000? Well, at 2 would just be a couple of blocks, but when you increase it to 2,000, it's going to flatten out. So you can say the graph would flatten out, or it's going to spread out, however you want to word that. And for 22, when will the graph be perfectly symmetric? Remember that from your notes, is when the probability of success is exactly 0.5. And 27, the sum of the values of a probability distribution is always less than 1. That is false. It is always exactly 1. Okay, that is important. In order to see if a probability distribution is accurate, the probability will always be exactly 1. So that is false. Number 28. A Waffle House offers 13 different kinds of waffles. How many different combinations of waffles can a family of 4 order if no 2 family members chose the same kind of waffles? So here we have, there's 13, and so we would just have 13 choose 4, and that'll give you your answer, which is 715. So it'll be 715 different ways that could happen. All right, let's look at 31. How many sets of 15 hits can a DJ select from the top 50 to play in the next hour? So this one, if you're wondering, so I'm guessing that the reason why people ask about this one is the E on their calculator. So I'm just going to show you how you'd set this one up. So we'd have 50, choose, and then there's 15. So 50, choose 15. So again, your calculator would give you something like this, or it'd say like 2.250 829, and it keep going on, and then at the end it's going to say E12. Here's what you do. E12 means times 10 to the 12th. So this is just scientific notation. So we would just say 2.25 times 10 to the 12th as your answer. Just know on the test, I'll either give you answers where, if it's a question like this, I might ask you what N and R would be, or I would just have smaller numbers where you're not going to get as massive of an answer where you'd have to use scientific notation. All right, 32. To pack for a trip, you can choose from the following items: 10 pairs of socks, 8 shirts, 6 pants, blah, blah, blah. How many different combinations are there of 4 pairs of socks, 4 shirts, 3 pants, 2 pairs of shoes, and a belt? All right, let's start with the socks. So there's 10 pairs of socks, and we're going to choose 4 of them. Okay, so I'm done with those. Next, there's 8 shirts, and we're going to choose 4 of those. So I'm done with those 2 numbers. Next, there are 6 pairs of pants, and we're going to choose 3 of those. So we're done with those. And then we have 5 pairs of shoes, and we're going to select 2 of them. So we're done with those. And lastly, we have 3 belts, and we're just going to choose 1 of those. So if you multiply all of those together, you're going to get an answer of 8,820,000. Now, if your calculator did it in scientific notation, you could also do this as your answer. 8.82, so I meant to put 8.82 times 10 to the 6th power. Those would be the 2 answers that I would accept for number 32. All right, let's look at number 34. It says determine the probability that all 3 balls are red. So what's going on here? We have a box that with 8 red, 3 green, and 9 white balls. 3 balls are drawn at random. So we want to find the probability that all 3 balls are red. Now, anytime we deal with the probability, and it's not a binomial probability, so this is not a binomial probability here. And the reason why it's not a binomial probability is we have the red, the green, and the white balls. We have 3 different colors here as opposed to just having 2 possible outcomes. So if that's the case, we're trying to find a probability. The first thing you're going to do is you're going to set this up as a fraction. In the denominator, we're going to put the total number of items. Remember, the denominator doesn't care what's going on as far as specific colors. It just knows that there's 20 balls. Because if you were to add together 8, 3, and 9, you get a total of there's 20 balls in the box. And we're going to be drawing 3 of them at random. So that's your denominator. Now, in the numerator, we know that specifically there are 8 red balls. And we're going to choose all 3 of them being red. Now, we could technically just leave it like that, but I know sometimes it might be a situation where maybe there's 1 of each color. Okay, so I want to make sure you can see how to set up our numerator. So what we're going to do is we're going to go next. It says that there's 3 green balls, and there's not going to be any that we're going to select from there. Okay, so it'll be just 3, choose 0. And then there's 9 white balls. Well, I can't write in white, so I'll just do blue. So we'll say there's 9, and again, we're choosing 0 of those. So here's what I'm getting at. If we have this set up properly, our numerator, the n values will all add up to be whatever n is in our denominator. So 8 plus 3 is 11, plus 9, sure enough, is 20. Our r values, oops, let me use a different color for that. Our r values, the 3, the 0, and the 0, when you add those together, should add up to be the r value in our denominator. So if that's the case, that's how you can make sure that you've got this set up correctly. But technically, 3, choose 0, 9, choose 0, those are both 1. But 8, choose 0, that's going to give us a number. I believe that's 53, if I remember correctly. Or, I'm sorry, 8, choose 3 is 56, rather. And then we divide that by the denominator. 20, choose 3 is 1,140. So when we divide those, you get your final answer, which would end up being 0.049. So that's how you do one like number 34. So again, the way that you know that you don't use a binomial probability is because a binomial probability only has 2 outcomes, a success and a failure. So this one you want to treat just like we did earlier in the chapter. All right, let's look at number 38. It says determine the probability that there are 7 sixes in 10 tosses of a fair die. Now this is a probability again, so there's a couple of different ways we could do this. We could actually look at this as because I determine the probability. So, okay, 7 sixes. Okay, so we're finding the probability of getting a 6. So in essence, we could treat this as a binomial probability. If we did that, there would be 10, so this is number 38 here. So we would have 10 shoes, and then we're going to have 7 sixes. We want to figure out what's the probability of getting a 6. We have a 1 in 6 chance of getting a 6, and we're going to get 7 sixes. Well, that means we have a 5 in 6 chance of it not being a 6, and that means if we're going to toss a coin 10 times, I'm sorry, roll the dice 10 times, then there would be 3 times where we would not get a 6. And when you do that on your calculator, you end up getting a decimal like 0.00, so 3 zeros, and then 248. Or if you said 0.0002, that would be fine as well. All right, let's look at number 39. It says, using the binomial probability theorem, determine the probability of getting at least 6 tails when a fair coin is flipped 10 times. Okay, so now this time we're looking at getting at least 6 tails. Okay, so let me erase some of this here. So when we see that word at least, that's significant, because that means we're going to have to do a bunch of adding together. So the way that I would set this up is I would say that, all right, so let's start with the first one. So we're going to have 10 times that we're going to flip a coin, and we're going to get 6 tails, at least 6 tails. So I'd have 10 choose 6, then 10 choose 7, because I could get 7 tails, 10 choose 8, because I could get 8 tails, 10 choose 9, and 10 choose 10. We're going to multiply that times the probabilities. Now it's a fair coin, so that means a 50% chance of getting heads, a 50% chance of getting tails. So this would be 0.5 to the 6th, then we point at 0.5 to the 7th, 0.5 to the 8th, 0.5 to the 9th, and 0.5 to the 10th power. And then we're going to take, so that's your probability of success, would be getting tails. Now probability of getting heads is 0.5 as well. So then we would have 4 times of getting heads with this first one. If we get 7 tails, then we're going to have 3 times where we'd have heads. If we had 8 tails, we'd have 2 times to get heads. If we had 9 tails, we'd only have 1 time getting heads. And if we had 10 tails, we'd have 0 times getting heads. What you would do is you'd find out what those actual values are. I'm not going to take the time to do that. You could do that on your own. But then that's how, when you add those together, that's how you get your answer of 0.377. Let's look at number 30, or number 40 rather. Number 40 says a coin is tossed 7 times. If the probability of getting heads is 0.5, what is the probability of getting exactly 5 tails? Okay, so now this one, it has the word exactly. So that means we're not going to have to add them all up like we had to do on the previous one. We're just going to do this once, and then that would give us our answer. All right, so let's see how we would do that. So we're going to flip a coin 7 times. We want to find the probability of getting exactly 5 tails. So we 7 choose 5. The probability of heads. Now here's where you got to be careful. So this is where I'm guessing, those of you that asked a question on this one, I'm guessing that this is where you got it wrong. The probability of getting heads is 0.25, but we want to find the probability of getting exactly 5 tails. Now there's 2 ways we could do that. If we have a 25% chance of getting heads, that means we have a 75% chance of getting tails, and we're going to get 5 of them. And then we could have 0.25 then to the 2nd power, because if we get 5 tails, we would get 2 heads. And when you do that, you get 0.311. Now the other way you could have started that one out is if you had done 0.25 here at the beginning, you should have had 0.25 squared, so you could switch these 2 around. So if we had done this, and if you had done 0.25 with the heads, the only way to get this right would be for you to recognize that if we're going to get 5 tails, that means we would get 2 heads. And so then we'd have 0.75 to the 5th over here. That would give us the same exact answer. All right, let's look at number 44. So number 44, it says, what is the probability that a student will get a perfect score if he or she guesses randomly? Well, I guess I should read the problem. It says that we're considering a multiple choice quiz with 10 questions that have 4 options each. So we have 10 multiple choice questions, and each one has 4 options. So we have a 1 in 4 chance of getting it correct. So we could say that P equals probability of success is 0.25. That means the probability of getting each one wrong would be a 3 in 4 chance, or 75% chance. So we want to figure out getting a perfect score. So if there's 10 questions, we're going to get all 10 questions correct. And we have a 25% chance of that happening, and we're going to get all 10 of them correct. And then that means we have a 75% chance of getting each one wrong, but that's going to happen with 0 of them. Well, 0.75 to the 0 power is 1. 10 choose 10 is also 1. So if you did 0.25 to the 10th power, you get a really small decimal. Again, your calculator might say something like this. So I'm guessing this is why if you asked a question on this one, this time you might have had a calculator give you an answer like 9e, and then -8, I believe it should be. Nope, 7. -7, sorry. I'm going to count the number of points on my own answer here. So 9.5e -7. So maybe your calculator said that. Well, just like you might have seen in the video earlier, e -7, anytime we see e on your calculator, it means times 10. It's scientific notation, so this will be times 10 to the -7th power. So we would just write that as 9.5 times 10 to the -7th power. All right, number 45. What is the probability? So this is 44. For 45, what is the probability a student gets at least 5 right by guessing randomly? So this is one where we're going to have to add a bunch of stuff together. So it says, and the reason why I know that is because it says at least. So again, we have I erased that and I should have kept it. P is 0.25, Q is 0.75. All right, so we're going to get at least 5 correct. So that means we could have 10 choose, 10 choose 5, 10 choose 6, 10 choose 7, 10 choose 8, 10 choose 9. Don't worry, on the test, if I had a question like this, I would not have you do this many items. So just want to make sure you understand the key concept. All right, then we're going to have probability of success will be 0.25, so this will be to the 5th power. This will be 0.25 to the 6th, 0.25 to the 7th, 0.25 to the 8th, 0.25, to the 9th, and 0.25 to the 10th. So probability of a failure, this would be 5, this would be 4, this would be 3, because again, these two exponents should add up to be 10, because that's how many questions there are on the test, or on the quiz rather. So we can put that one in as 0.75 to the 0 power just to keep up with the pattern. But when you add all these together, you end up getting your final answer of 0.078. Or if I asked you to do it as a percent, you'd say 7.8%. All right. Let's look at numbers 48 and 49. I'm not going to go through the process of 49. There were more people that asked about 48 than there were about 49, and I'm guessing that if you asked a question about 49, you probably also had a question on number 48. So 48 will be a little bit smaller, a little bit shorter for me to have to do, but at least this way you can see how to do it, and then you can still have one to practice. So this will be probably the only one that I don't do on this video would be number 49. So the first thing I'm going to do is I'm going to change all these probabilities from percents to decimals. So it'll be 0.096, it'll be 0.003. If you're wondering why that'd be 0.3, it's because we divide by 100 or move the decimal to the left 2 places. Just because it already has a decimal doesn't mean that it's a decimal, it's just a percent, showing a decimal percent there. So this will be 0.001. So we are going to use these values instead of the ones in the table. So the first thing, to find the mean, I'm going to take each value for x, multiply it times the probability. So 2 times 0.9 plus 4 times 0.096 plus 20 times 0.003 plus 40 times 0.001. And so again, this is one where you type this in on your calculator. When you do that, you get 2.284. That would be the mean. Now to find the standard deviation, we're going to go through a very similar process. We're going to start out with, so again, I'm just going to cross this out. So we're going to start out with squaring the 2. So we'd have 2 squared, or 4, times 0.9, plus 4 squared, or 16, times 0.096, plus 20 squared, or 400, 0.003, plus 1600, or 40 squared, times 0.001. So we take each of those and do the same thing that we did up here, except for we square those x values. Now that's not our answer. That's just the first step. So we're going to subtract from that whatever the mean is squared. So minus 2.284 squared. And after you do all of that, the third step is you're going to take the square root of that answer. So again, you're going to do this in 3 steps. I'm going to actually do this in a different color. So the first step you would do is all of what I had in green. Type all of that in your calculator all at once in one step. Hit enter, and then type in minus 2.284 squared. Hit enter, and then take the square root of that final answer. And when you do that, that is the standard deviation of the data, which for number 49 ends up being 2.28. That's your standard deviation. All right, getting to the end here. Number 52, if all the items are true or false and students, this is a test with 40 items. So if all items are true or false and students guess randomly, what is the mean and standard deviation of the random variable representing the number of questions answered correctly? Okay, so if it's a true or false quiz or test, that means the probability of success is 0.5. The probability of a failure, getting it wrong, is also 0.5. So to find the mean, that's where we just take the number of trials times the probability of a success. So 40 times 0.5 would give you 20. To find the standard deviation, that's where we take the square root of n times p times q. Oops. So 40 times 0.5 times 0.5, and then we take the square root of that. And when you do that, you get 3.16 approximately. You round it to the nearest hundredths place. So that's number 52. Now 53, this one says, if all questions are multiple choice with 5 options, okay, so you got to be careful. Just because it's multiple choice doesn't mean it's always 4 options. And students guess randomly, what is the mean and standard deviation of the random variable given the number of questions answered correctly? Okay, so here we have a probability of success is, if there's 5 options, we have a 1 in 5 chance, or 0.2, of getting each one right. That means we have an 80% chance, or 0.8, of getting each one wrong. So we're going to go through the same process. So to find the mean, we would take the number of trials, which is 40, times the probability of a success, which is 0.2. And when you do that, you end up getting 8 as your answer. Oops, equals 8. And then to find the standard deviation, we're going to take the square root of 40 times 0.2 times 0.8. And when we do that, we get 2.53 as our answer. All right, so for number 60, it says find the first 4 terms in row 15 of Pascal's triangle. Well, the first 2 rows are easy. It should be just 1 and 15. Now, to figure out the third term, we're going to have to use, since we're in the 15th row, we're going to use 15 choose. Then we've got to figure out what we choose. Now, remember, we start out with the first term would be 15 choose 0. The second term would be 15 choose 1. So the third term would be 15 choose 2. And if you do that on your calculator, you end up getting 105 as your answer. Then that means to get the fourth term, we're going to do 15 choose 3, which would be 456. That's how you can get the first 4 terms of Pascal's triangle in row 15. For number 63, what are the last 2 terms of the row in Pascal's triangle whose terms add up to be 220 or 2 to the 29th power? Now remember, the sum of any row is 2 to the nth power, whatever row we're in. So this tells me I'm in the 29th row. And the last term of any row is always going to be 1. Okay, so the last term is 1. And the first term is 1. The second term in any row is going to be what row you're in. Remember that the Pascal's triangle is symmetrical. So that means if the second number is what row you're in, the second to the last number is also what row you're in. So 29 and 1 would be the last 2 numbers in row 29. All right, number 68, tell why the table does not describe a probability distribution. In order for us to do that, remember, probability distribution, the probabilities have to add up to be 1. So this is hard because they have different denominators. So I'm going to change this 1/6 to have a common denominator with the 12s. So 1/6 is the same as 2 12ths. Same thing with 1/3. I'm going to multiply that by 4 to get 12 in the denominator. Whoops. And so I'd multiply the numerator by 4 as well. 4 times 1 is 4. So let's add those numerators together since we have a common denominator. So we're going to add all these together. So 2 plus 1 is 3, plus 7 is 10, plus 1 is 11, plus 4 is 15. So that is not a binomial or probability distribution because it doesn't add up to be 1 exactly. All right, let's end with number 71. The graph of the binomial is given below. What is the mode of B? So the mode is not, it's the highest bar, but it's the along the x-axis. What value gives us the most? And so 10 would be the mode there because 10 is the bar that's the highest. So you don't want to make the mistake. Like if this was a multiple choice question, and if I had 0.25 as one of the choices, you would not want to say 0.25. The mode is the actual value that, or the actual number that is used the most. And so this would be 10. What happens to the mode as n increases? So as n increases, the mode is also going to increase. Again, if you want to see how that works, you could set this up. You could do something similar to this on your in that one table and play around with it and see what happens as n increases. What happens to the mode? Well, the mode is also increase. What happens to the spread of the distribution as n decreases? Okay, what happens is the spread. So as n decreases, as the number of trials decreases, the spread decreases. So in other words, instead of being a nice curved line or maybe even more flattened out, it's going to become more blockier. So the spread decreases, so it becomes more blockier. However you want to phrase that, That would be your answer for C. So a question like that, maybe instead of having you describe it, I might have like a bunch of choices, like a multiple choice question, and you'd have to select the one where the number of terms would be the least amount based on the shape of the graphs. So that's how you would do number 71.